Saturn, planet, moons, rings, water. Brazosport Planetarium, Center for the Arts and Sciences online planetarium show. How interesting on a clear night to see a first quarter moon in the Earth's sky, and it's even more interesting to see the rings of Saturn through the large lens of this camera. Looking back from Saturn, Earth could be seen from the Cassini spacecraft as it orbited Saturn. The planet Saturn has very low density. If there was a pool of water large enough, it would float. To have such low density, it must be composed of very light elements, and it is. Hydrogen and helium, the two lightest elements, make up most of the mass of Saturn. Despite being mostly made of the lightest elements, we do detect water on the planet. Saturn's most defining feature is its beautiful ring system. This is where the water is. Close up, the rings might look like this, a jumble of roundish water ice blocks orbiting the planet. Saturn's rings are almost entirely water ice, 99.9%. Viewed edge-on by the Cassini space probe, the ring appears very differently. If you were to make a model of Saturn, the very thinnest sheet of paper would be too wide to represent the rings. To your left, you see the large shadow of the very tall rings. The small dot on the ring is an orbiting moon. Saturn's icy moon Enceladus blasts Saturn with a constant spray of water and organics. These watery blasts give Saturn's upper atmosphere the signature of water. Saturn is twice as far from the Sun as Jupiter, a place of incredible cold. Scientists expected to find that the water in the outer solar system would have formed somewhat differently than the water that formed the warmer inner solar system close to our Sun. Water is formed of 2 hydrogen atoms and 1 oxygen atom, H2O. If an extra neutron is part of one of the hydrogen atoms, the water will be heavier by about 5%. This form of hydrogen is called deuterium. Planets usually have both forms of water. Inner planets have mostly normal hydrogen. Deuterium can change how a planet, comet, or a moon develops. When we explore the solar system, we look at the hydrogen-deuterium ratio, H to D, to understand how and in what part of the solar system water formed. We expect to see more hydrogen closer to the Sun and more deuterium further away. We recently discovered that Saturn, its rings and moons, have water which is very like Earth's water. This was surprising enough that we must rethink how we describe the formation of the solar system. Some of Saturn's 82 confirmed moons orbit in the rings themselves. These moons also have water like our Earth. How about larger moons? Saturn's moons, Titan and Rhea, pictured by the Cassini spacecraft, show the differences in the moons of Saturn. Rhea's sharp outline and heavy craters indicate that Rhea has no atmosphere. The fuzzy edges of Titan show a thick nitrogen atmosphere, heavier than Earth's. Liquid on Titan. Earth and the moon Titan have amazing similarities. Earth and Titan are the only known bodies in the solar system to have stable liquids on the surface. The processes are similar, but the chemistry is vastly different. Titan's lakes are filled with hydrocarbons like methane rather than with water. Soot, not snow, builds up on the surface. It rains on Titan, but the rain is more like gasoline and not water. Shown here in another wavelength, the light brown soot-covered land around the dark Titan lake is water ice covered with solid organic material. The liquid hydrocarbons flow in to fill the lakes, the rivers, and oceans. Lakes and oceans are deep and filled with methane. This is the surface of Titan taken by the Huygens space probe. The rounded rocks in the foreground are pebbles of frozen hydrocarbons and water ice, each about 4 to 6 inches across. It's thought that this is a riverbed and that it sometimes floods with liquid methane, perhaps seasonally. Titan's liquid bodies include surface and subsurface lakes and oceans containing organic molecules. The great bodies of liquid include water, methane and other hydrocarbons, and ammonia. What we don't know is the exact composition of the ocean, its density, its thermal profile, and the overall structure of the icy crust on top of it. Deputy Principal Investigator Mike Malaska. Phoebe is different. It is unlike any other planet or moon astronomers have studied. Worn and heavily cratered, Phoebe has the highest amount of the deuterium form of water we have seen so far. The carbon of tiny Phoebe is also a much different form of carbon than we have found in the Saturn system or in the planet systems closer to the Sun. This moon likely formed in the far outer solar system. It was probably captured by the huge gravity of the Saturn system. Across the solar system, we see strong evidence of water as liquid, solid, and gas. New explorations of the Saturn system show an exciting variety of water. Rocks and land masses made of solid ice, liquid water like Earth's water, and gaseous sprays carrying complex organic compounds. Finding water in all its forms and in so many systems is challenging everything we know about the role of water in the solar system and how we understand its formation.